Assalamu alaikum, my name is Muttalib. I'm second semester first year student in Faculty of Computing. I'm taking Network and Security course, and today I'm going to try to explain the past year question for midterm test for the course Computational Math. And I already solved it a little bit earlier, so I'm just going to explain it question by question. So for question 1, we are given a matrix A, and for A here we need to find the cofactors of this matrix. To find the cofactors of this matrix, we're gonna use this formula: cofactors ij equals to -1 I plus j a ij. Here I and j is the number of the row and the column. And what is the cofactor? So the cofactor is, for each element in the matrix, when we cross it, we are left with a submatrix, and when we find the determinant of this submatrix, so this, for each element in this matrix, when we find the determinant of the determinant there we are left with, and when we get the matrix of all of the results of these determinants, we're gonna have the cofactors of the matrix. So first, let's say we start with row 1 and column 1. So when we cross row 1 and column 1, we are left with 3, 2 and 1, 1. And we're gonna calculate the determinant of this matrix. So to calculate this, we just cross this diagonal and minus multiplying of this diagonal, and we find this. And what is this use of this formula? We see the power of the element we are using is it's -1 to the power of number sum of the row and column. So for first row and first column is 1 plus 1, so the sign doesn't change. But for first row second column, let's say first row second column, the sum would be 1 plus 2, so we're gonna have the negative sign before the determinant. As we can see, we can refer to this table: first element positive, second negative, third positive, and so on. So we're gonna calculate for all of the elements of the matrix the determinant, and we don't forget these negative signs and put everything in its place. So after calculating these determinants for all of the elements of the matrix, at the end we just put it into the one matrix. So A11, A12, A13, we put it in the first row, and so on for second row and third row. So we are done for the first question. For second question, we need to compute the determinant of the matrix A. So to calculate the determinant, we just multiply the coefficient of the place when we cross it. When we cross and we get the coefficient in the cross place, we just multiply this cross with the matrix, with the minor that we got here, with the determinant of the submatrix. So as you can see, we can do it with any row and column, but here I calculated with first row and first column, so we just calculate it here. So it's 2 times A11, and for second one is 3, and for third column is 3, so 3 times A12 plus 3 times A13. So we just calculate it and sum it. So when we do it, we're gonna get the determinant is equal to -4. And for question C, we need to find the inverse of the matrix A. To find the inverse of the matrix A, we have this formula. It's A inverse, which is denoted as A power of -1, is equals to 1 over determinant of A times a matrix of cofactors transposed. So what does mean transposed matrix. Transposed matrix when we change the rows and the columns in the matrix. So here, to find the transpose of our cofactors matrix, we just change, let's say, this first row and make it first column. So 1, 2, negative 4 will be in the first column, and so on for this second row and third row. We're gonna put it in the second column and third column, and after this we just multiply transpose matrix to 1 over determinant, and we get this as an answer for inverse of the matrix. And for question D, we are given the linear system in the matrix form a minus 1x equals to b, and a power of minus 1 is from question 3, which we already have, and b is equals to 1 minus 2, 2. And it's said to solve it with crowd factorization, and they already gave us the lower triangular and upper triangular as L and U. So to calculate this, let's first write our matrix in the form of the equation. So we put our matrix here, a power of 1, we put the x row, and we put our b. And to calculate all of this with a crowd factorization, first we need to write it L times U, which is lower triangular and upper triangular, should be equal to our A, which is, this is our matrix. So now we're gonna calculate everything. So we already given L and U, so we're just gonna find the missing entries or variables. Here we have L21, L32, L33, U13 and U23. So to find, it's not that hard to find these variables. So let's say for L21, to find L21, let's say when we cross product of the two matrices, so when we multiply this line to this line, we will get this element. So it means to find this element, we need to cross, to multiply this row to this column and corresponding element in the matrix. So when we multiply everything, L21 times 1 plus 1 times 0 plus 0 times 0, which is two other elements are 0, so I'm not going to write it. So it will be only L21 times 1 equals to negative 1 over 2. And from here we can find L21 is equal to negative 1 over 2. And we're going to do it for all of other elements. Let's say here we're going to do it for element U13. As you can see, corresponding to this, it is 3 over 4 in the matrix. So to find 3 over 4, we multiply first row to third column. When we multiply first row to third column, we're gonna get 3 over 4. So to do all of this, we multiply this first element to second element plus second element to second element plus third element times third element. As we can see, second element, third element are 0, so we're not going to write it. We just write first element times second element equals to 3 over 4. And from here we can find U13 is equals to negative 3. And we're going to do this for all of other elements. For U times 3, you can see it's in second, and the corresponding in the matrix is negative 1 over 2. To find negative 1 over 2, we multiply this row to this column. So multiplying second row to third column, we're gonna get this number, -1/2. As you can see, I did it and I got an answer -2. So I did it for all of other elements in the ways that I just told you, and when I got all the elements L21, L32, L33, U13 and U23, so after this, to calculate the system, linear system, first we gonna do it in two steps. First step, we gonna multiply L times Y equals to our B, which is given here, and L is our triangular, lower triangular. So we're just gonna multiply our lower triangular times Y equals to our B. And I calculated this, and how to calculate to find Y1, we're just gonna multiply this to this and we get -4, and for Y2 we multiply this to this and we get -2, and for Y3 same, we multiply this by this and we got 2. So in second step we're gonna multiply upper triangular times X equals to Y, which we got here already. So we're gonna multiply this in the same way. So first row times second times our Y, and we're gonna get it. So as we can see, here we only have one variable with a number and other is 0, so it's better to start from third row and to find x3 first. So we just multiply this to this, and when we multiply it, we're gonna get x3 is equals to 2. So we're gonna do the same for all other elements, and at the end we're gonna find the answer. It's 2, 0 and 2. So we solved the question 1, which is the answer for x is 2, 0 and 2. So for question 2, here we have, for A, we have considered the vectors u and v with a given coordinates, and in 1 we need to find magnitude of the vectors u and v. To find the magnitude, as we also call it norm in linear algebra, so to find norm or magnitude, we just find the sum of the square of each coordinate under square root. So as you can see, you just square it and each coordinate, and then sum it, and then get the square root of it. So for u we got square root of 14, for v we got 5, and for second we need to find distance between vectors u and v. To find distance between vectors u and v, we gonna do it with this formula. It's gonna be u minus v magnitudes. So we gonna minus first vector minus second vector corresponding elements, and then we're gonna square it, then sum all of these things, and at the end all of it is under square root. So the distance between u and v, we will find it will be 61. And for third, we need to find angle between vectors u and v. To find the angles, the formula is u times v equals to magnitude of u times magnitude of v times cosinus sigma. So we need to find here cosinus, the value for this angle. So to do this, first we need to find u times v. To find u times v, we just multiply u1 times v1 and plus u2 times v2 plus u3 times v3, and from here we will just get the values and put it here. So negative 2 times 4 plus 1 times negative 3 plus 3 times 0, and we get negative 11. And after this we just put into the formula, so cosine of sigma here would be equals to u times v over magnitude of u times magnitude of v, which is, we calculated u times v already, and for magnitudes we have magnitude of u is for a square root of 14 and magnitude of v is 5. So we just put it back, and to find the angle we just cosine negative 1 and put our value and put into the calculator, and it's something would be equal to 126 degrees. So this is done for question A, and for question B we are given vector u and vector v in R3, and we need to find cross product of the vectors. So to find the cross products there is several ways, but the easiest way is to do it as the determinant of the matrix 3 by 3. So we just put our, in the first row we put I, j and k, and in second row we put our first vector, and in third row we put our third vector. So we just calculate it as we did in the first question, how to calculate the determinant. So it would be when we cross first column and first row, it would be I times determinant of the left, the matrix that we are left with. So we calculate it and we get the answer like this, and after this we can write it in the vector notation. In the vector notation we just write it u times v equals to negative 27, negative 18 and negative 3. So this is how to calculate the cross product, and the easiest way is this to do is with a matrix 3 by 3. And for the question C, we are given set of vectors in R3, and we need to determine whether it's linearly independent or not. To check if the given vectors are linearly independent, we need to calculate that given vectors times with the arbitrary scalar, and when you plus it, it will be equal to 0. So C1 times first vector plus C2 times second vector plus C3 times third vector, it would be, if it is equals to 0, so it means it is linearly independent. So we're gonna do it. So but first, before calculating, as you can see, our second vector and third vector are exactly the same. So when it's the same, or it's something times, like you can write one of the vectors in the set as a subset of another vector, you can just conclude that these vectors are dependent. Let's say we have another vector is equals to negative 4, 6 and 8. So you can see here it's like twice the first vector, so it's subset of first vector, so it means the vectors are already dependent. So here we see that they are repeating vectors. It means we can write v1 equals to 1 times v2. So it is linear combination. From theorem we know that this vector is linear if a vector is a linear combination of another vector in a set of vectors then these vectors are linearly dependent. But to make sure, we're just gonna calculate making it equals to 0. So when we calculate it, we just times some scalar times two vectors, and we sum it and equals to 0. To calculate this, you can calculate as a normal system of linear equation, or you can just write as a row echelon form and reduce it. I hope you guys can know how to reduce the matrix to its row echelon form. So when I reduced the matrix, you can see each step. So first I changed the matrix, the first row and third row, because it's easier for us to have here the number 1. So I changed it, and for second operation I did the row 2 would be equal to row 1 plus row 2, and for third row it would be 5 row 1 minus row 3, and when you calculate it you will get this. So row echelon form means you need to get 0 here in the lower triangular, like here, here and here. So after one more set of operation and one more, we're gonna get this form at the end. So as you can see here, after doing this, we're just gonna substitute our C back. So C1 times this, C1 times first, column C2 times second, and C3 times third vector. So we're gonna get this system of linear equation. So C1 plus C1 plus 4C2 plus 4C3 equals to 0, and for second row you will see C1 is 0, so C2 plus C3 equals to 0, and for third row we don't have anything, it's just 0. So here you can see C2 is equals to negative C3. So, and when we calculate for C1, C1 is equals to 0. So our result is this. So we can see that our equation has infinite number of solutions. So let's check here. So let's say our C2 is equal to 5. So when we put 5 to C2, our C3 would be negative 5. When we put 5 and negative 5 here, it will satisfy the system, our system. But since it's non-trivial solution, because we can have any number instead of C2 and C3, so since it's non-trivial solution, these vectors are linearly dependent. What's non-trivial means? Non-trivial means our scalars here would be any other number except 0. When all the numbers are 0, C1, C2 and C3, then it means our system has trivial solutions. So but here we have infinite number of solutions, so it means it's non-trivial, it has non-trivial solution. So we are done with question 2, and for question 3, here we can see we are given set of matrices, and we need to determine whether S is the basis of matrix 2 by 2 and justify your answer. So to check if the given set of matrices or vectors are basis of given matrix or vector, we need to check two conditions. First, we need to see if we can span this this given set to be in the form of our matrix, or if it's given vector. And for second condition, we need to see if it's independent. If it's not independent, then it means given vector or matrix is not the basis. So if any of these conditions fail, we can say that this given vectors or matrix is not the basis. So to calculate it, I started with the first condition. To calculate it, you get the arbitrary matrix size 2 by 2. So I got matrix A with elements A, B, C, and D. And to find the basis, we just multiply some scalar with the given matrices, and it should be equal to our arbitrary matrix of the size, or if it's vector, so it would be vector. So we just calculate this. To calculate, we just put it back to augmented matrix, then row reduce it. To do this, we start from first element. So first element of each of the given matrices should be equal to first element of the arbitrary matrix. So 1, 0, 1 would be A, and 1, 1, and negative 1 would be B. Then 0, 2, and negative 4 will be C. Then 1, 1, and negative 3 would be D. So after doing this, we reduce it to row echelon form as we did in the previous question. We do it with a simple equations like this, and when I finished this row echelon thing, the row echelon form of the matrix was like this, and you can see after each operation our system became this: A, B minus A, C minus 2B plus 2A, D plus 2A minus B. So when we make it equal to 0 and calculate it, we can see if it's dependent or independent. And from this system, we can see that the solution for linear system is inconsistent. So S is not a basis of the matrix M size 2 by 2. So system is inconsistent means it can't be solved, or when you solve it you get the infinite number of solutions. So here this was the question A, and for B we are given a matrix and its row echelon form, and we need to find a row vector, column vector, row space, column space, null space, and nullity of given matrix. So first let's start with the row vector. Row vector is simply all the rows in the matrix, and we can say them as a row vector. So row vector 1, row vector 2, row vector 3, and row vector 4. So we can write it like this, and it's from our matrix, not from its row echelon form. So for column vector, it's again same. So we have first column vector, second, third, fourth, fifth, and sixth. So as you can see, all are here. And for 3, we have row space of A, and row space of given set of vectors is when you row echelon it, and when you row echelon it, you can see the leading numbers. This is called the leading non-zero numbers. So each leading non-zero numbers will be one row space. So one row space, we have this, second row space, and third row space. In the fourth row we can see it's all 0, so it doesn't have row. It's not considered as row space because it doesn't have any non-leading number except 0. It's all zeros. So our row space will be R1, R2, R3, this row, this row, and this row. And for column space, we look for the corresponding non-zero entries first that we can see. So here, this column, and this column. And corresponding to these columns, we get these columns from our original matrix. So this will be our first column space, this will be our second column space, and this would be our third column space. And we get it from our original matrix. So we get C1, C2, C3, first, second, and third from here. And for the null space and nullity, so to find the null space, the matrix times x have to be equal to 0 from our row echelon form of the matrix. So as you can see here, to calculate this, I put x2, x4, and x6 equals to s, t, and u. Why I put this variables but not x1, x2, or x3? Because these variables called free variables, because when you see, they are not first non-zero in the row. So this is first, and as you can see in x2, we don't have non-zero leading elements. So our free variables would be this, second, fourth, and sixth. So we just put them to some, make them equal to some numbers, so we can express other variables as such as x1, x2, x1, x3, and x5. We can express them in we can express them with these variables we just created here. So for x5, we come here. For x5, it would be x5 plus 5 x6 equal to 0. So our x6 is u. So x5 plus 5u equals to 0. So we can find x5, it will be negative 5u. And we will do it for all of other elements for x3 and x1. So you can see here for x3, it's x3 plus 3t minus 2 times our x5 minus 6u. We can find x3 is equal to negative 3t minus 4u. And for x1, it will be equal to 3s plus 14t plus 37u. So we put all of it into the single matrix. So you can see I put x equals to our variables. So first, for x1 we have this, for x2 we have s, for x3 we have negative 3t minus 4u, and for x4 we have negative 5u, and for x6 we have just u. And after this we need to write it in the span of the vectors. So to write in the span of the vectors, we just get the scalars, our variables, out of the scope. So first we start with s. So when we take s out, we can see for first element we have s, so we write it here. For second element we have s, we write it here. For third, fourth, fifth, and sixth we don't have s, so it means it's 0. And next we plus and we get out the t. So t times, we see we have t here, so we put 14. For second element we don't have, so we put 0. For third element we have negative 3, so we put negative 3. For fourth element we have just t, so it's 1. For fifth we don't. For sixth we don't, so we just put 0. And we do the same for u. And after this is called the null space of the given vectors. So the null space is the span of these three vectors. So to find the nullity is the number of free variables or the number of the vectors in the null space, which is one vector, two vectors, and three vectors. So our nullity is equals to 3. So for question C, we are given to vector B, and with its ordered vector B prime is given. So first we need to find the coordinates of vector V is given relative to B. To find a given vector to be relative to a set of vectors given, you need to make it like this: CV1 plus CV2 plus CV3 equals to the given vector. And so when we calculate this, we're gonna get C1 equals to -1. And to calculate this, we just do it as we did in the previous questions with a linear system. So C1 times 1 plus C2 times 0 plus C3 times 0 equals to -1. So since these ones are 0, we're gonna just left with C1 time equals to -1. So we do this for all of other elements. So C1 times this, C2 times this, plus C3 times this equals to 0. And for third one, C1 times 1, C2 times 1, plus C3 times 0 equals to -1. And after solving, we're gonna get C1 equal to -1, C3 equal to 2, and C2 equals to 0. And we're gonna write vector V relative to given set of vectors B. Coordinates of this vector will be -1, 0, and 2. And for second, it's asked to compute transition matrix from B to B prime. And to calculate this, we're gonna put the vectors in the set of B to denote them V1, V2, and V3. And we do the transition of matrix like we did for the first vector. So we're gonna do it for all of the vectors for B, for the set of vectors B. So first we're gonna do for B1, and second we're gonna do for V2, and third we're gonna do for V3, exactly the same as we did for the vector V. But here we're gonna change, we're gonna find the coordinates of vector 1, vector 2, and vector 3 and the relative to B prime. So we're gonna just write A1, this is any variable, you can name anything. So A1 times our first vector in B prime plus A2 times second vector in B prime plus A3 times third vector in B prime equals to, we are changing the first vector in B, so equals to 1, 2, and 1. So we're gonna calculate it as the same as we did in the question 1. So when we calculate, we're gonna get this vector. So when we find the coordinate of V1 relative to B prime, 3, -1, and 0. And we're gonna do the same for vector 2 and vector 3. So as you can see, A1 times first vector plus A2 times second vector plus A3 times third vector from B prime equals to, now we are in second vector in B, so equal to 0, 1, 1. We calculate, we get this answer. And we calculate for vector 3, and we're gonna get this answer. So 1, 0, 0. And to write the transition matrix, we're gonna write it like this: I and here b, here b prime, the ordered base, here base with basis of the vector. Here is the ordered ordered vectors, basis of vector, and we're gonna put it into the one matrix. So v1, v2, and v3. So this is how we calculate the transition matrix from B to B prime. And for 3 it said use transition matrix found in 2 to find coordinates of the vector v, which is we were given this vector relative to B prime. So to find this, it asked us to use the matrix. So to use the matrix from the formula, it's v, vector v relative to B prime equals to transition of matrix B to B prime times vector of v relative to B. So we just substitute, this is our transition matrix times our given vector times of vector relative to B. So we found vector relative to B in the beginning already. It was equal to -1, 0, and 2. So times -1, 0, and 2. We just do it as a normal multiplication, first row times all of these in the first element. So second row times all of this, second element, and third times this third element. And when we finish calculation, we're gonna get the answer of this: -1, 1, and 0. So vector v relative to B prime would be, the coordinates of vector v relative to B prime will be -1, 1, and 0. And this is how we calculate it. And for question 4, it is define a mapping of the transaction from R2 to R4 given by T vector of xy, and its image is x plus y, x minus y, 2x, and -x. And first we need to determine whether T is a linear transformation. So to check if it's a linear transformation, we need to check two rules. First, if it is closed under addition. So to check this, we need to make sure that transformation of u plus v equals to transformation of u plus transformation of v. So to calculate here, we just let's say our u is equal to x1 and y1, and v is equal to x2, y2. So u plus v will be x1 plus x2 and y1 plus y2. So to find first this one, transformation of u plus v, we're gonna put this is our first element, this is our second element. We're gonna put these elements into the image that we had in the beginning as a given. So this is our first element, this is our second. So to calculate, we just put, this is our first element here, this is our second. So we just substitute. So our first element is x1 plus x2. So we just substitute this first element into first element here. So x1 plus x2, first element will be instead of first element, and second element instead of second element. And second row here, it is, we just substitute it back again. So x1 plus x2 minus our second element, y1 plus y2. And for third one, it's 2 times first element. So 2 times our first element, x1 plus x2. And for third one, negative first element, and negative, our first element is x1 plus x2. So this is t transformation of u plus v is equals to this. And to check, we need to find transformation of u plus transformation of v and see if they are equal. So to find this, we do the same. So for transformation of u, as you can see here, transformation of u, our u is x1 and y1. So our first element is x1 and second element is y1. So we just substitute it back into the given image. So to find its image, we just put first element instead of first element here, and second element instead of second element here. So it would be x1 plus y1, x1 minus y1, 2x1 minus x1. And for t transformation of v, we use our v, which is first element x2, second element y2. So when we put everything substitute like we did for tu, we're gonna get x2 plus y2, x2 minus y2, 2x2 minus x2. So since it's plus, we can just plus element by element. So first element here plus first element here, we write in the first element. So as you can see, x1, since it's plus, we can just write x1 plus x2 and plus y1 plus y2. So for second one, we can also write, since it's plus here, we can write x1 plus x2 minus y1 plus y2. So in third one, 2x1 plus 2x2, we can put 2 out of the scope, so it would be 2 times x1 plus x2. And for third one, we can put negative 1 minus negative 1 out of scope, so it will be x1 plus x2. As we can see, both tu plus v and tu plus tv are same, so both results are same, so additivity is checked. We checked. And second, we need to check if it's closed under scalar multiplication. To check this, we need to see if transformation of cu equals to c times transformation of u. So to find transformation of cu, as we did here, our u is x1 and y1. So we just multiply our scalar to the elements. So c times x1, c times y1. We already hit here, so we just put it, and this is equal to cx1 plus cy1, first element, second element. We just multiply it with c, so cx1 plus cy1, and second cx1 minus cy1, and third 2cx1, and third negative cx1. And from here we can put the c out of scope. When we put c out of scope, it will be x1 plus y1, x1 minus y1, 2x1 and negative x1. Since we already found the transformation of u is x1 plus y1, x1 minus y1, 2x1 and negative x1, this is transformation of u. So c transformation of u, we can write just c transformation of u, and we can see we found transformation of cu. It was equal to c times transformation of u. Since we checked and this satisfies both properties, t is linear transformation from R2 to R4. So for question B, and here for question B, oh no, not question B, here we have 2. It asked us to find the pre-image of V equals to 7, 3, 4 and negative 2. To find the pre-image, we just substitute. We need to make sure that the transformation of given vector is equal to the pre-image. So to calculate this, we just make image, this is our image equals to pre-image. The given transformation equals to pre-image. So we just calculated it as a normal linear system of linear equations. So x plus y, first element, our first element here, first equals to first element here. So x plus y equals to 7, x minus y equals to negative 3, 2x equals to 4, and negative x equals to 2. And from here we can see x equals to 2, and from here again x equals to 2. It means it is consistent since it's same. And from here y equals to 5, and from here y equals to 5, and it's consistent. So our pre-image will be 2 for x and y, 5 for y. So we are done for second question. And for question B, as you can see, we are given transformation from basis of 3 to basis of 4, and it is said it's already linear transformation, so it means we can use linear transformation properties. And let B equal to E1, E2, E3 be the standard basis of R3. Okay, so this given vectors are standard basis in R3. So suppose that transformation of E1 equals to this, transformation of E2 equal to this, and transformation of E3 is equal to this. And for first, it asked us to find transformation of V, find transformation of V where vector V is equals to 4, negative 1, and 2. So to find transformation of TV, transformation of V, we need to find the image of vector V with the basis vectors given, with the vectors that are already given. We need to check, we need to find the image. So to do this, we're gonna do this vector, the given vector, equals to C1 times vector 1, C2 times vector 2, C3 times vector 3. So this C1, C2, and C3 are the elements from the given vector. So C1 is 4, C2 is negative 1, and C3 is 2. So we just multiply it with the given vectors, with the transformation of with the given transformation. So from as you can see, V will be equals to 4a1 minus a2 plus 2a3. So from linear transformation properties, linear transformation of V equals to linear transformation of V1 plus V2 plus V3. So we can use this property, and from given equations that we already got, transformation of V will be equals to 4 times transformation of E1 minus transformation of E2 plus 2 times transformation of E3. This 2, negative 1, and 4 we got from the given vector. So we just substitute it. So TV would be equal to 4 times first vector, negative second vector, plus 2 times third vector equals to, when we calculate it, it's just 4 times 1 minus 2 plus 2 times negative 1, so it will be equals to 0. And we do this operation for all of other elements, so for second, third, and fourth, and we're gonna get the answer. Transformation of V will be equal to 0, negative 4, 10, and negative 9. So for second question, is vector W in RT? So we need to check if vector V is in the range of RT. So to find this, we need to check this with this equation. So some arbitrary variable some constant times transformation of V plus C2 transformation of V2 plus C3 transformation of V3 equals to the given vector, to check if this vector is in the range of the RT. So we substitute back everything, so C1 times the given vector, transformation of given vector, 1, 0, 2 and negative 1. So for C2, C3 we do the same, and it's equal to the given vector W. So after this we just calculate it as we did before with this linear system equation. So for first one, C1 plus 2C2 plus negative minus C3 equals to negative 3. So we do this for all of other elements and we calculate. So from here C2 is equals to negative 1, then C3 is equals to 3 and C1 is equals to 2. And since the system has solution, the given vector W is in the range of RT. And for the third question it said find the kernel of T. To find the kernel, it should be C times transformation of given vectors equals to 0. So kernel, in other words, is called null space. So to find null space, we just times some constant to the given vectors and sum all of them and make it equals to 0. So as we had we had the same, we will have the same system, but only here would be 0, 0, 0 and 0. When we calculate it, we're gonna get C1 equals to 0, C2 equals to 0 and C3 equals to 0. So we can see that we have all trivial solutions. So when we have all trivial solutions, so the kernel will be the only vector solution of the vector. So it is kernel of T will be 0, 0 and 0, and the nullity will be 1. It's not asked, but we said that number of vectors in null space is called nullity. So for question C, we are given a linear transformation from R4 to R2. So this is transformation, and when we transform this from R4 to R2, the image will be 3a minus b, and here will be b plus 2c plus d. So now we find a basis of the null space of T and its dimension. So as we said, the basis of null space is the kernel, so we're just gonna get the image that is given and make it equal to 0 and calculate it. So we make it equal to 0, and from here we can see b is equal to 3a and d is equal to negative 3a and negative 2c. A and c are free variables here. Why a and c are free variables? Because we can, as you can see here, we can express b with a. So when we express b with a, so when the express c, the things that we're going to express the other variable with are called free variable. So here we expressed b with a is free variable, and here express d with c and a. We already said a is a free variable and also c is free variable. So we just say that our a is equals to s and c is equals to t. So as you can see here, a equals to s, so we just write it. B equals to 3a, so a is equals to s, so b is equals to 3s. C equals to t, and d is equals to negative 3a minus 2c, so negative 3s minus 2t. From this, when we write it in the vector space and in the basis of the vector, as we did before, we just take s out, and we see in the first element we have s, so it's 1. Second element we have, it's 3. In third element we don't have s, so it's 0. In third element we have -3, so it's -3 plus t. So first element we don't have anything, it's 0. Second element we don't have anything, it's 0. Third element we have 1, we just write 1. And for fourth element we have -2, we just write -2. So the basis of the null space or kernel of given t is equal to two vectors, this vector and this vector. Since there are two vectors, the dimension is equal to 2. So this was all. Hope you guys understood and hope I was clear. Thank you.